Guys, in this video, what we're going to be doing is the down and dirty of getting started using the Johnson Controls Controller Configuration Tool, also known as CCT. Before we get started, guys, I would appreciate it if you would subscribe to my channel, like and share the video, and leave me a comment down below, and let's get started. So what we are going to do in this video, I'm basically just going to show you the raw basic elements of how to get started using this program. I've got several videos out showing different aspects of this program. It is a very powerful tool in programming controllers, and the more familiar you are with it, the better off you're going to be. However, for those of you guys who are new to this software, that's what this video was going after. I'm trying to basically give you guys some fundamental principles that you can use to begin your programming journey within CCT. What we have in front of us here is the blank screen that you will see once you open the software. Now, just to show you the version that I am currently running, I am running at 10.6. This is the version that I am currently running on my system and the one that we're going to be using for our demonstration. So guys, again, this is the bare bones slate. This is what you see when you first open the program. So to get a little more specific into some of the basics of what we need, we're going to begin with one of the easiest programs that we can write, and that is for a VAV. This is something that you guys will be doing as part of your job, I'm sure, if you are using this system. So we're going to go up here to File, and I want to select New. This is how we would create the various files, the various programs that we're going to use within our system. Now, this is the pop-up window. This is going to, of course, give us the release mode that we're going to select for programming. This is also going to be able to select the type of controller. You can see here with this particular release mode that I'm setting at of 10.2, the selection that it gives me here are a wide range of controllers for this particular version. I'm going to go ahead and change that to 10.6. That way it's going to match the revision that I'm currently running on my system. And the controller that we're going to be going for is the CVM 3050. This is a very common CVM, a very common VAV controller. So that is the one that we are going to select for this particular project. I'm going to highlight that and select OK. It's going to give me this next pop-up window where it is basically going to give me the option for system name and that sort of thing. And what we're going to call this, of course, you can call it whatever you want, but you do need to limit the character width. When you go crazy with trying to give these things very long names, you can run into some issues trying to pull them into metasis. For this example, what I'm going to call it is simply test VAV. Something simple, something, of course, you know, that we're not going to be keeping. You know, and there again, it's just a demonstration purpose. If you're writing this for a for a building or whatever, if you have several VAVs, you might even call this just something even simpler, you know, whatever your building name is, VAV. If all of those VAVs, or the majority of them, are going to be using the same program, you will be able to take this program, change a couple of things, and load it into multiple controllers. Now, that is the system name. The system type is our next drop down, and of course it is defaulted to air handling units. I want to change that. What I want to change it to, of course, is VAV. Okay, that is what we're going to be programming. The system configuration. Now, single duct and dual duct. I have talked about this before on other videos on my channel. If you go back on my channel and check those out. Single duct is basically one set of air ducts that is going to supply air from the air handler, and then potentially the VAV could be running some type of a reheat. Dual duct is basically you're going to, what it sounds like, you're going to have two sets of duct work, one for heating, one for cooling, that the VAV will be controlling. For this example, we're going to go with single duct. Of course, our system of measure, we're going to keep that in imperial. You do have the option for metric, but here in America, we're going to use the imperial system. So once I get that selected and hit OK, it's going to take us to this selection tree. This is basically where we're going to tell the system what we have for our system, the physical components, the physical elements of our system. We have, of course, here the supply damper actuator. This, for most part, for that 3050, is an integrated actuator. Depending on the model of controller that you're going with, there are some controllers out there that are a controller only, and then they will be tied to a separate actuator. But again, for what our purposes, it is going to be an integrated actuator. But depending on what I needed, I could select a proportional actuator or an incremental actuator, and we'll get more into that in a different video. We'll leave that selected to integrated, and then of course I have some other options here. If I had an exhaust damper that I was controlling as well with part of that, I can make that selection here. If I have a fan, there again, right here, the same thing that I can select here. I also have these drop down tabs that gives me a few more options as well. Again, if I did select an exhaust damper, I could select whether it was a proportional or an incremental actuator. As far as a box fan, it's going to give me some additional points, some values that I could select for that output as well. For the coils, for this, of course, it is going to have a reheat coil. Again, this is just our example. It is currently selected as incremental actuator. Guys, for the years that I've been doing this kind of work, I'm going to have to say I am a bigger fan of proportional actuators because they are much easier to troubleshoot, and it just makes your life a lot easier when you're up in a ceiling. You're needing to know if you have the signal that you need coming from your controller. Simply override the output to whatever you need, and then simply measure the voltage if you're using a 0 to 10 volt signal. Incrementals are a little bit different. And again, we'll get into that in a future video. Two position is basically open, closed, on, off. There again, it could be depending on your output. If you're driving a relay for an electric heat coil or just whatever, that's something that you would select here as well. But for this example, we will select proportional because there's some other things that I want to show you once we get further into the video. Again, there's all these other options here. I can select lighting control, calibration solenoid valve. There's just everything you can see. If we have supply air temperature, I can select that here. You can do some comparisons with that if you are wanting to monitor what the coil or the reheat is doing. But again, the discharge air temperature sensor is something that is very useful in a VAV. It really helps you to troubleshoot several things within that VAV. Especially if you're trying to see if you have a reheat valve that is not functioning properly. If you have a discharge temperature sensor as part of that system, it is much easier to do. You can literally troubleshoot it remotely before even going down to climb into that ceiling or wherever that box is located. Now that we have that selected, our zone temperature, this of course is set point adjust is what it has defaulted to. Common set point adjustment is what we are set for here. I'll also have the option for warmer cooler adjust, which that's what I'm going to go with. Basically up or down from the common set point of the building or of the room. And of course here I could select it where then the occupants or whoever would be able to change the room temperature set point however far we give them in the programming, right here. But for me, for how we use it typically, it is just a warmer cooler up and down a couple of degrees each way. We also have temporary override support. If you have humidity sensors, occupancy sensors, CO2 sensors, you would select that here. You also have some miscellaneous points here, energy hold off switch, and so on. The N2 compatibility mode. Now, this is something that you guys will eventually need to become familiar with, especially if you are going to be doing this line of work for a while. There's still a lot of N2 networks out there that you will need to replace devices on. If you are going to be replacing a VAV that is on an N2 network, you would need to select that, and then of course select the type or the series of VAV that you are replacing, and that will go ahead and configure a lot of the programming for you. It will help get everything set up for where you can flip the communication of the device from BACnet to N2. We're not going to be doing that in this example, in this demonstration, but I may do that in the future. I've got some other videos talking about that on my channel, so go over and check them out. Now I'm going to select next. We have this screen up as well, and you can see what we have as far as our options here. Box heating control, the coil control, of course it's basically zone control is all it is. I could do discharge air reset. There's other options here. Scheduled occupancy, I'm going to leave that checked the way that it is. When you pull these points into your system, if you do run a schedule for your VAVs, if you do have some type of a schedule, you will want to pull up the occupancy schedule point when you pull it into your system. Heating priority, of course box heating used first. Okay, of course that's what we want to do. We want to use the reheat coil for heating. Again, there's other options here depending on what my system needs are. We're just going to leave the rest of these default, and I'm going to select finish. Okay, and it's going to take this just a moment, and it's going to populate our program. Now what we have here on this screen, we're basically going to be working from left to right. On the left side of our screen over here, we have all of the inputs. We have our network inputs. This is stuff, just basically software points that you're going to see on your system once you pull them in. Here is the occupancy schedule point that I told you about earlier, that you definitely would want to pull into your Metasys system, or if you are running a Jace, into your Tritium system for scheduling. That would be what you would tie to a schedule. And then of course here are the physical inputs: the discharge air temperature, the velocity pressure, and so on. The warmer cooler adjust, the zone temperature sensor, and so on. We also have some additional miscellaneous inputs. These are basically software inputs, I guess you could say. For example, we have our damper position and our heating percent and that sort of thing. Inside here is all of the logic. These three blocks here, again, this is going to take some of the variations, your inputs from the controller, from the sensors, and this is where the magic happens all through here. We're not going to be able to go through all of that in this video, but we are going to look at a couple of things to help you to understand and navigate a little bit better in this system. For example, if I wanted to see exactly which logic block was affecting the heating output of my controller, I can come over here to my outputs, and again, the output section, we have network outputs, we have physical outputs, which we see here are damper, heating output, and so on. We also have miscellaneous outputs, and again, guys, go over check out my channel for some of those other details on these points. But here, now that I have the heating output, you can see the signal that I have here, 0 to 10 volts DC. Let's hypothetically take and imagine that we have a milliamp signal. What I can do here is I can actually right-click this, and I can modify that signal. Okay, I can simply click that modify, and I have the option of changing it to a 4 to 20 right here, or just whatever I need. So that's something, if you're wondering about this, once you're going through your system, if you got an actuator for a heating valve or whatever, well, my heating valve isn't 0 to 10, it's a 4 to 20. You can go in and you can change that here. Very simple. You can do the same with an input. For example, let's look at our zone temperature. I'm going to right click that, and I'm going to select modify signal. If I pull that up, again, I have all of these options here. I can change that to whatever I need. Okay, I have the 4 to 20. I have just whatever I need, just right here. And again, make it match what your physical equipment is. I'm just going to cancel out of that now. Of course, the heating output. Another thing that you need to be paying attention to is the direction of those outputs. For example, once you get your system up and running, if the damper is mechanically set the way that it needs to be, now depending on how a VAV mounts, your damper may need to rotate clockwise or counterclockwise for a particular position. For example, some boxes, that damper actuator may need to rotate clockwise to open the damper and counterclockwise to close it. Or you may be in a situation where the box goes counterclockwise to open and clockwise to close. The way that you can control that, if you double click into that particular output, again guys, this is just raw, down and dirty, getting you into the basics of this. If I double click into that output, you see this option here of priority, okay, or polarity. I'm sorry, I can't read today. Right, I go up here and I hit edit, and if I needed to reverse the direction of that, I can change that here, okay. I can select normal or reverse, depending on what I need for that particular output. It is the same with my heating valve, okay? If you get up there, you get your heating valve wired up, and that heating valve is working opposite as what you need it to be, okay? For whatever reason, I'm simply going to go in here. I'm going to view details. That's another way. You can either double click it or you can view the details. This one's a little bit different. You don't have that polarity option. What you do have is your hardware setup, you have your engineering values, you have your min and max output. What you will do in this instance is you're going to hit the edit button. I'm going to change these two values here. That minimum output, what I will do is I will change that to 100, and then the maximum output, I would change that to 0. Okay, that will reverse the direction of that output, of that heating valve actuator. Okay, very simple to do. Okay, so don't let that confuse you. And it's the same if you are working with a damper in some cases. Okay, depending on that output, that damper, you may need to do that the same way. You know, it's simply by swapping that minimum and maximum output value. That's how you can change the direction of your outputs. Okay, very simple to do. Now from here, we have pretty much most of what we need. This is a bare bones system. We could basically load this into a system, change a few values, and have a VAV up and running. There's still a couple of things that we need to change before we do that though. The first thing we need to do is we need to go into the define hardware. Okay? If you don't do this step, you're going to basically cause an error. It's not going to let you try to load it. It's going to give you an error when you do try to load. Okay, this is our first screen. It's basically going to give us the option of looking at our VAV type again. You can see here what our VAV type is right here on screen. I also have point assignments. This point assignment tab is the physical location of each of those control points. The discharge air temp sensor, the heating output, and of course it does show, even though it is an integrated actuator, it does show that a particular point that these, you know, the damper output is connected to a physical output. At least that's how it shows. There again, it's integrated into that box, so there's no wiring that you have to do for that. Of course you do for the heating output, the discharge air velocity pressure. You will see those tubes. And those tubes is what you would connect to where the box could read the airflow. Now, of course, your balance guys, they're the ones that's going to come in and going to set that up. They have the equipment to read what that box is actually flowing. And, of course, once they get onto your system, they will be able to manipulate the values to whatever they need to be to where they are calibrated properly, to where that box is calibrated properly. And I highly recommend, guys, if you work with the folks that are doing your jobs or whatever, or if you are the guy doing those jobs, write that down somewhere. Set you up some kind of an Excel spreadsheet. Set you up something to where you have those values listed somewhere for future reference. If you have to replace one of these boxes and you want to make sure you get all of those balance values back in there, that will come in very handy to have that data available. Something that you also need to look into is the network settings. This is where you're going to set the address for your device. Of course, what we have here, this particular device is basically an IP device. If I was using it a different revision or whatever, I would have the option of setting a network address. Okay, I would be given basically whatever my network ID is. That's where I'm going to enter this. Now, it's going to be a little bit different for an MSTP device versus an IP device. Of course, this is an IP device as far as what it is set up to be. A controller number, the IP address, IP mask, of course, most of the time, depending on your network, this is set up DHCP enable, and so on. You will need to set up your network settings prior to loading the programming into your device. Okay, that's something that it will not let you do prior to, or after you have already loaded it in there. You need to set this up beforehand. Okay. Of course, then we have our packages. This is basically the different packages we have. The default screen, the N2 mapping, if we were on an N2 system, if I had selected that earlier, this would be available for me, but we did not set this up as an N2 device, so I do not need to worry about that. So I'm just going to close this window out. Down here, I wanted to take a look at some of these tabs through here. What we have here, we see some of the parameters that are inside the box. Again, this is just basically bare bones out of the box programming that we see. If I highlight one of my points, what I can do here, I'm actually going to right click this and I'm going to show involvement. And when I select show involvement, it turns these blocks, all of these blocks are going to have some effect on that heating output, all of these logic blocks. What I can also do is I can select this connections tab and then I can click on that point, and it's basically going to show me the exact block prior to that output. This is where my connections are made. This is where it is literally a control logic block is connected to one of these outputs. Okay, and one of these outputs is then connected to a physical output underneath the point assignments, and I can move these if necessary. For example, if this heating output, for whatever reason, I needed that output to be used for something else, I could simply grab this, and of course you see this error that has given me right here. Let's go ahead and click that, and then when I try to move that, it's not going to let me. Okay, the container port already contains an assignment, and the reason for that is I just didn't drag it. I got to click and drag. Okay, when I drag that down, it basically reassigns that point to a different output, and I can move that around. You know, I have a couple of options here to where I can move that to. For this particular controller, I have two configurable outputs. I also have the binary outputs, and it is the same with an input. These are all universal inputs. I can grab that input there and I can drag it down just like this. I can move that around depending on what I need it to be. Okay, so let's go ahead and close this out and go back to our connection screen. Okay, again, we have this pulled up. You can see here this blue highlighted area here. What I'm going to do is I'm simply going to click that, and what you will see is that somewhere in this list, once I click it properly, for whatever reason it's not wanting to work with me today, highlight that, click the proportional control. That proportional control is right here. This is the block that is controlling that output. I can click on this, I can see all of the connections into it, and so on. You know, I can basically just walk myself back. I can also go in and I can view the logic of this particular block. I'm not going to get into the various states in this video. Again, this is just to get you guys up and running. Okay, and again, this is the programming, and if I needed a little more room, right up here in the right corner, I can select the maximize, and it's basically going to make that connection block go away, and I have a little more room to view everything going on in my programming blocks. Okay, all of my state blocks and so on. To get back, I can simply hit Control, and of course, then I can hit Minimize. I can just hit that same block again and bring up my connection panel. State tables, that's something for a future video. This is basically, it's going to be easier to explain if we're actually watching things happen in a box and a live device to help you understand these. They are a very powerful tool that you will need to understand to be effective in this. display. We're not really going to get into this a lot, but there are ways of setting up, like for your map gateways and things like that, different types of displays and all that. There's a lot that you can do in this section here. We can go into advanced. It's just more advanced features that we're not going to be covering in this, as well as backnet exposed. This is where it's going to tell you some of the points that you do have that are exposed to backnet and so on. But again, guys, it is a very powerful tool, a very useful tool, and this is the basics of getting a VAV up and running. That's all this is, guys. That's the intention of this video. We're going to be talking about some other things in the future, and hopefully get you guys a little more information on how to go in and how to program your systems. But guys, hope you liked the video. I would appreciate it if you would give it a thumbs up, leave me a comment down below. Thanks for watching. Subscribe, check out the rest of the videos on my channel, check out all of the links down below. Those are affiliate links, and anything that you buy through those helps to support what we do here. There's also super thanks. You can become a channel member. And guys, thanks for watching, and we'll see you next time.